Now we're going to talk about the relationship between the trigonometric functions of an angle theta and minus theta. Sometimes these are called the even and odd function properties. And this is really, really important. And I'm just calling this a giant bullet, by the way. It goes, we started a bulleted list in the last handout. This is another bullet, but it gets its own video. All right, so what I want you to try to imagine is, so on the unit circle, imagine an angle theta in standard position. And now I'm also going to draw minus theta. So minus theta, we kind of come down like that. And then the coordinates of this point on the unit circle are going to be cosine of theta, sine of theta. So the x-coordinates cosine, y-coordinates sine. And if this is minus theta, then the coordinates of this point are cosine minus theta, sine of minus theta. Okay. And these 2 points are related to each other by the symmetry of the circle, right? I mean, you can believe that you can go straight down from one of these points to the other. Those 2 points being vertically one above the other means they have the same x-coordinate. So I'm just going to same x. And also, due to the symmetry of the circle, maybe this isn't quite so obvious, but I'm sure you can believe it. Here's the y-coordinate of this point. Here's the y-coordinate of that point. I think you can believe that those are opposite y-coordinates. Opposite y. And really, just that picture, same x, opposite y, gives us a formula. By same x, these x-coordinates are equal. So I can actually write down that cosine of minus theta equals cosine of theta. And that's true for any angle at all. Even if the picture were in a different quadrant, it would come out the same way. It's a little bit more complicated, but not very, for sine of minus theta. We're saying sine of minus theta and sine of theta are opposites of each other. So sine of minus theta is minus, the opposite of sine of theta. And this is true for all theta. And this is incredibly important properties of sine and cosine. So it's a way in which they differ, because so much about sine and cosine makes them seem similar. But this is a way in which they're kind of different, and it gets its own card. And we call it the even and odd function properties. Well, I'll say why in just a second, but the main thing is to get the property down. So cosine of a negative is always equal to cosine of positive. Sine of a negative is always equal to the opposite of sine of the positive, always. And the reason they're called the even and odd function properties is this cosine property applies to the even powers of x. Because if you take the square of a negative number, that's equal to the square of a positive number. If you take the fourth power of a negative, it's the same as fourth. All even powers. The sine property is true of all odd powers of x. So if you take like the third power of a negative, it's always going to come out to be the negative of the third power of the positive. So that's where the words even and odd function come from, and why these are called the even and odd function properties. But I don't care if you remember the name. You just got to remember what's in the box. Now let's do a couple exercises here where we make use of this. Oh, this is exercise 1 because we're starting a brand new section. That's right. So the book has problems like this. They say if cosine t is 3/4, what is cosine of minus t? So you kind of have to get see what they're getting at here. They don't really want you to figure anything out. You're just going to apply this property. You need to know that cosine of minus t equals cosine of t. So t is some angle. We don't know what it's, some specific angle. We don't know what it is. But the cosine of the minus of that angle has to come out the same. So it's equal because cosine of minus t equals cosine of t. Number 2, if sine of t of some angle t is 2/3, what is sine of minus t? Okay. Well, again, you just have to know how this property works. Now you can put the minus sign on either side, by the way. We could have put minus sine of this as that, or this is minus sine of that. It comes out the same. So sine of minus t is minus sine of t from our property, which is negative 2/3. Number 3, if cotangent of t is equal to negative 4/3, what is cotangent of minus t? Now, I didn't give you a property for cotangent, and I don't think we need one. I could have given you the corresponding properties for tangent, cotangent, secant, cosecant. I think we just figure it out each time. That's my feeling. So we're going to use what we know about sine and cosine. Use what we know. So what's up in the box up above? So in general, for any angle at all, let's see, cotangent of minus t is always cosine of minus t over sine of minus t. Cosine over sine. Now we apply this property to each one of these functions separately, or they each have their own property, right? So cosine of minus t is cosine of t. Sine of minus t, however, is minus sine of t. So do you see where this is going? We can pull that minus sign out in front of cosine t over sine t. And that can be interpreted as minus cotangent t. So it turns out cotangent has an odd function property just like sine. I wouldn't memorize it, I just figure it out when I need it. So we got to answer this question now. Cotangent of minus t is minus cotangent t. Now cotangent t for this angle was negative to begin with, right? We started out with cotangent t equals negative 4/3 here. So we got negative and negative 4/3. If it's negative to begin with, it's going to flop back to a positive value. Okay. And, okay, I'm going to stop there. I think we're going to have one more video segment on this section with just, a couple of, now we're going to just do it right now. A couple of odds and ends, because these are very minor things. So there we got even odd function properties, really important. Okay. I'm just going to call this odds and ends. Exercise 4. If secant t is negative 5/2 and tangent t is negative square root of 21 over 2, find sine t. So this is not a hard problem at all, and it's just kind of using what we know about the functions. All right, what these two equations are telling us. We're given this, and we're given this. Now I know if secant t is negative 5/2, I know 1 over cosine t is negative 5/2. So cosine t is negative 2/5. I just flip it, right? If tangent t is negative square root of 21 over 2, I know sine t over cosine t is negative square root of 21 over 2. And now what we can do is we can just substitute this value in for cosine t. So we're talking about a specific angle here, right? Like we have some specific angle involved. Sine t over negative 2/5 is equal to negative square root 21 over 2. And now we can just solve for sine t. So it's like all the information was there, we just had to juggle things a little bit. Here I can multiply both sides by negative 2/5, and we get sine t is equal to, I think the 2's are going to cancel, the negatives go away. This is going to be square root of 21 over 5, positive. Okay, that's exercise 4. Nothing scary about exercise 4. Exercise 5, I think I got a couple more little ones here. They just are not always obvious in the textbook. Simplify secant t times cotangent t. Like we're going to see a lot of these manipulations where you just try to simplify something in trig. And one of the most common ways to simplify in trig is to rewrite using sine and cosine. So secant is 1 over cosine t. Cotangent is cosine t over sine t. And we're multiplying. Oh, so we can cancel cosine. And what we have is 1 over sine t. And actually, I like 1 over sine t as an answer, so that's perfectly okay. Or if you want to show off, you could say, oh, it's cosecant t, right? It's the fancier way. So either is an okay answer. There's no real reason to think one is better than the other. They both say the same thing there. Okay, so that's exercise 5. And I think I got one more. And this is really easy, but I just want to make sure we've talked about it a little bit. Find secant of 11 pi over 5 using a calculator. And we do so much in this class where I'm saying, don't use a calculator, gotta do it by hand, don't use a calculator. And then I find out that people don't know how to use a calculator at all, and I have a heart attack over it. So you want to make sure you can do something like this on a calculator. Now, most calculators do not have a secant button. I guess some fancy computerized things might, but you don't need a secant button, right? All I have are sine, cosine, tangent on my basic scientific calculator. So we can use the fact that we can express this using cosine, right? This is 1 over cosine of 11 pi over 5. So really all I got to do is use my calculator to figure out the cosine of 11 pi over 5 and take the reciprocal. Now here I got to be in radian mode, because when no units are given, it's understood we're in radians, and I can see, I don't know if you can see, but my calculator is not actually in radian mode right now. Now it is. Switched it to radian mode. And I just enter 11 times the pi button, I don't know, equal, divided by 5, And there's 11 pi over 5. Of course, my calculator is going to want a decimal. And I am in radian mode. So now I just hit cosine. And there's the cosine now. I have a 1 over button, so I can just hit reciprocal. And there it is. There's my decimal. It'll be a messy number, 1.236 so 1 rounded off to 4 places. And, okay, that wasn't a big deal. So I don't think any of this was a big deal, 4, 5, or 6. But the real big deal that I want to flip back to is this guy, this property, this relationship between cosine and sine about negative theta and theta. I think that's, our material for chapter 7 is through. We're going to be moving on to chapter 8 and graphing. We're finally going to get to step 4, stage 4 in the next chapter.